Kia ora, year 11 and 12. This is the last question from the booklet of ancient questions that I gave out in class today. So it's the differential equation question about the rectangular reservoir. So let's have a look at the question. It's quite a long question, but it's not too bad. It's a little bit different from the usual ones. Rectangular reservoir has a horizontal base area of 1,000 metres squared, and you know that I'm going to tell you to draw a picture of that straight away. All right, so this is my base reservoir. Oh, look, it's drawn really nicely. So we know that the base of that is 1,000 metres squared, and we're going to call the height of that h. At time t equals 0, it's empty. Water begins to flow into it at a constant rate of 30, and at the same time water flows out at a rate proportional to h. And when h is 1, dh by dt is 0.02. We have to show that h satisfies this differential equation. Then we're going to solve that dE down here and get an expression for t equals. Okay. Lastly, we're going to figure out when is the depth of water 4 metres. So let's start off by getting an expression for dV by dt. But first you should pause the video and try and get as far through this question on your own as you can. Okay. But let's take a look at what we've got. Well, we know the volume of a cuboid is length times width times height. So in this case, it works out to be 1,000 h, which gives me dV by dH is equal to 1,000. And then we can get an expression for dV by dt. So dV by dt has got the water coming in at 30 metres per second, and then it's got water going out at a rate proportional to root h. So it looks like that. What we're asked to find, though, is dH by dt. We want to show that it satisfies this equation here. So what will dH by dt be? Well, we need to use the chain rule. It's going to be dH by d something times d something by dt. And, of course, the missing link in here is volume. Okay, so dH by dt is going to equal 30 minus k root h times, that's the dV by dt part. Now, dH by dV was 1,000, so dV by dH was 1,000, so dH by dV is the reciprocal, which is 1,000. So that's what we're starting with. Right, now we need to do some work to figure out the constant because we're asked to get it down to this point here. So we've got no k in there. We need to find something out using our initial conditions. We're told that when h is equal to 1, dH by dt is equal to 0.02. So we substitute that in. 0.02 is equal to 0.03 minus k root 1 over 1,000. That gives me negative 0.01 is equal to negative k over 1,000. And that leaves me with k is equal to 10. Okay, so we're just about there. We just have to do a last bit of cleaning up. We've got dH by dt is equal to what? Where did I go from? Yeah, 30 minus that constant times 1,000. 30 minus 10 root h. So that gives me 0.03 minus 0.01 root h, which is just about what I want. Factorising that, we get this as required. So that's the first part done. Okay, not too bad. I think the only tricky bit in there was remembering, of course, that you're going to need the chain rule sometimes. If you're doing level 3 calc, should be all good with it from related rates problems anyway. And up here, the next thing we have to do is to take this equation and to solve it using this fact here. Right, so let's look at that. Well, we've got x minus 3 times dx by dt is equal to 0.005x. Separate the variables, and we'll get x minus 3 over x times dx is equal to 0.005 dt. Now we're going to integrate both sides, and over here this gives me x minus 3 log x, and here we get 0.005t plus c. Now we're told that at t equals 0, what are we told? Hang on, just have to go back up and check. Okay, we're told that when t equals 0, x equals 3, and we actually could have figured that out for ourselves from the facts, but they gave us that. So we're going to substitute this into here, and we get 3 minus 3 log 3 is equal to c. So putting that back in, we get x minus 3 log x is equal to 1 over 200 t plus 3 minus 3 log 3. So let's take everything to one side except for the bit with t in it. X plus 3 log 3 minus 3 log x times 200 is equal to t. So that's my solution to the equation. We had to get t equals blah blah, and the last part of the question makes us solve a problem with that. Right, so we've got the expression for t in terms of x, so we've got 5 marks, which is nice. And now we have to figure out when will the depth of the water be 4 meters. So the depth of the water being 4 means h equals 4. So x is equal to 3 minus root 4. So we have to figure out what t is. So x is equal to 1. So it's a very nice, easy substitution. We don't even have to rearrange. T is equal to 1 plus 3 log 3 minus 3 log 1 times 200. That goes, of course, and we end up with t is equal to 259. I think we're working with seconds to 3 significant figures.